In this presentation, we're going to look at logic networks. Now, this is the logic network question from 2001. Draw a logic network that accepts independent inputs P and Q and gives as output P or Q. Sorry, P, not P. Let me start again. Not P and P or Q. So, let's just get our notation right. P or Q. Whereas that means not P. And this means and. So not P. Now again, that's an important, just get those right, those symbols right in the first instance. Label your diagram to show the symbolic output after each gate. So that's an important step. So don't forget to actually properly label your diagram. So in the first instance, what we're going to do is to start off with our channel from P. So this is our input P, and what we're going to do here is add a, that's not a very straight line. This is we're going to have it going to a NOT gate. So we're going to look at this part here first, and that's the NOT gate there. And the output coming out of that is not P. So hang on, we'll just start this again. Let's label everything. So P goes in there, and at this stage it becomes not P. Now, so that's that part. Now we have an input Q. Let's have Q come from here, and it's going to go into an OR gate. Okay. Now the other input, so that's the input Q. The other input is P. So this is the channel coming. This is the input from P. So we can actually draw a line from here, and it goes in down there. So out of this comes P or Q. Okay. Now, let's just put in a few little remarks there. That's P going in there, that's P going in there, that's Q going in there, and so on. Now, so we have two components. We have the not P component and we have the P or Q component, and they're going to meet each other in an AND gate. So let's draw in our AND gate now. And the AND gate, it looks like this. Sort of D-shaped, and the output of the AND gate is not P and P or Q. Okay, and those are the inputs there again. I mean, it's not absolutely necessary to put every little detail on your logic network, but again, it does actually say label your diagram to show the symbolic output after each gate. So it's a well-labeled diagram. It would help here. Actually, what also would help here is, I'm going to do this here. I'm just going to write in the names of the gates beside them, even on them actually, just to make it absolutely clear. Now, make a table to show the truth values of the output from the network correspond to each combination of the truth values of P and Q. So what I'm going to do is I'm going to set this up here again on the next slide, and what we're asked to do is come up with a set of truth tables for this statement here. So that is not P and P or Q. Okay, so this is coming up with a set of truth tables here. So first off, I'm going to start here by writing in P and Q. Let's try and get straight lines going there. There we go. And what we're going to do there is fill in those. So 0, 1, 0, 1, 0, 0, 1, 1. You notice I started from the right hand side and then moved leftwards. Now the next thing I'm going to do, I'll do this next one in black. This is not P, and that is 1, 1, 0, 0. The next one I'm going to do is P and Q, P or Q, and that is just, that's a sort of using a basic definition. So where do we have P or Q? And they would have, the truth table for that is 0, 1, 1, 1. Essentially, is there at least one 0 in the two component parts? Or sorry, if there's at least one 1 in the two component parts of an OR gate or an OR statement, then we have a 1. So that's just a basic definition. It's probably these are the type of things that you should know off by and an OR are the things you probably should know off by heart. So the next we're going to put them together. So not P and P or Q. So an OR gate is at least one true state, at least one 1. For an AND gate, they both have to be 1. Okay, so in that case, this is 1, but this is 0, so that's a 0 there. This one here is 1, and this one here is 1, so that's a 1. 0 and 1, that's a 0. 0 and 1, that is a 0. So that there is the truth table we are asked to construct for this question, this one here. So that ends the presentation for this part.